So basically, this workshop is principally focused on handling PPE shortage through innovation, creativity, maker movement. We hope that basically we can organize the community and figure it out a way by which we can effectively help Keck as well as hospital all around the country. I am SK Gupta, most people call me SK. I direct Center for Advanced Manufacturing at USC. I'm a professor in Aerospace and Mechanical Engineering Department and Computer Science Department at Viterbi School of Engineering. So next slide, please. So the background basically behind this workshop is that a large number of people want to help. A very large number of designs are being shared by the community. However, many of these designs have problems. So there are subtle issues, things don't quite work. Now the challenge is that if everybody keeps pursuing by, downloading design from the internet and start iterating on them, it's not a very, good way or effective way of helping at this time of crisis. Keck people, as you would hear from them, a little bit later, has already been collaborating with, lots of their collaborators to develop solutions that actually work. So it will be good if we learn about what those solutions are and help Keck in basically making sure that we can produce a solution in quantities which are proven to work. So that's what I'm hoping that we can do that. The other aspect is that some areas are receiving a lot of attention. So, face shields, it seems that a large number of solutions are out there, people are working on it, while others still require attention, in which, people are currently not working in large numbers on those. So it will be good to learn about those as well, and then see if we can, channel our energy towards things which people are currently not working on. And I want to, again, re-emphasize that we really need to work closely with Keck to make sure that we are actually helping, because in the end, if we just randomly produce some design and simply tell Keck that can you test it, it's actually not helping them because they are already busy. As you will see in Darryl's slide, he's sleeping 2 hours a night. Reducing his sleep any below is not going to be helpful overall for the community. Other thing is that it is very difficult to acquire materials and supplies. So we need to really coordinate and pool our resources. So if in our lab we have certain material already there, perhaps somebody knows how to cut it or process it more efficiently. Maybe we can just share the material as opposed to our fabrication services. So I think we need to figure it out how to get coordinated and organized to help. Next slide, please. So workshop objectives are the following. First, we want to learn from people at Keck about the challenges and requirements. What would they like us to do? What would actually help them? The second aspect is that we will get an update on what's ongoing, what is being done, what designs have been approved, which we can all help in basically scaling up the production. And the third aspect is that we want to organize a community so that we can work effectively. So if I have a laser cutter and somebody else has a 3D printer, perhaps we can partner to make sure that we can create a product which will require both laser cutting and 3D printing. So I think if we can organize a community, that would be helpful. And of course, if people know material suppliers, then that would be great as well. So one more thing that I want to point out, I know that everybody is locally building their own repository. I know Viterbi has an effort, Keck has an effort, individual investigators have their thing. So nationally, America Makes is one of the Manufacturing USA Institute, which has been now tasked to build a national repository. So they are basically building a national repository for 3 types of users. So healthcare providers can input what their needs are, and their needs then basically get distributed to manufacturers who submit their capabilities. And then you can basically do some matchmaking and figure it out who can make things for you at scale. And designers who have creative designs can actually submit designs as to what new things that they have come up with, what the status of basically different approvals are. So this way they are trying to connect healthcare providers with designers and manufacturers. So this is a repository where you can select the role that you want to play, and then you can start searching for people. So this will all enable matchmaking. My prediction is that in about 10 days or 2 weeks from now, you will start seeing useful material posted there. But I would like to encourage all of us to look at it and start posting things there, because that way we can have a national impact as opposed to purely local impact. Next slide, please. So basically, observation that I would like to share is that additive manufacturing is a fantastic and very useful technology. But remember, all fabrication cannot be done using 3D printing. So we need to look at basically other options as well. So let's not ignore laser cutting, molding, water jet cutting, machining. So we should keep exploring those options as well, because ultimately to scale up production, we will need to use these other processes as well. And hopefully Kim will educate us on the sanitization component of this overall work, but this is going to be extremely important that we make sure that we pay attention to it. Next slide, please. This is my last slide. So next steps in this workshop are that let us learn from each other about the challenges and discuss potential solutions during the breakout session. And then we will do a detailed follow-up, basically with all registered participants after the workshop to understand your capabilities. And then we will build a community. And that way, basically Keck people can use that community to address the challenges and get the fabrication done.
Okay. Good morning, everybody. I'd like to introduce myself. I'm Kim Lengyel. I'm the Associate Administrator for Hospital Epidemiology and Infection Control here at Keck. So basically, I'd like to start with a little bit of a summary based on our confirmed cases that shows that basically our slope has not flattened yet. There are various models out there to determine the effectiveness of social distancing. We don't quite know yet if we have days to prepare, weeks to operationalize our PPE and then the way our hospital functions during a surge. So this could happen at any time, and we would expect a duration of a surge to last about 6 to 8 weeks. And this is really dependent on social distancing right now. So if we have mild social distancing and compliance with that, we could delay our county-wide ICU occupancy all the way, maximum occupancy, from May 9th, with full occupancy being around May 16th. That doesn't account for any added from our patients from our Department of Defense, our SNFs, our ambulatory settings. If we have moderate social distancing, we could further delay that full occupancy all the way out to July, possibly with full occupancy being in August. It's just hard to say at this point. Next slide. So this is some of our current state in LA County, which I'm sure you've heard on the news. Mortality is doubling on an average of every 3 days. These are stats from yesterday at 12 p.m. We have had 4,045 confirmed cases in LA, 78 confirmed deaths, and 879 confirmed hospitalizations. At Keck, this is a very important slide, because though our occupancy for these patients is not at our peak yet, you're going to see in slides to come how much PPE we're actually burning through every day to make this very significant. So this slide will show you that the slope curve, how much time or how little time we actually have to operationalize this when we're at 85% occupancy. This next slide that we're on, the next slide shows that the personal protective equipment that we're looking for healthcare workers. Can you go back one, Tiffany? Yes, so the preferred PPE, what we're currently using today at Keck, and we want to actually continue to use at a minimum of this PPE, is our face shield with our N95, gloves, of course, and an isolation gown. There are other forms of PPE that are considered effective, but right now, our preferred method is as described. Next slide. So personal protective equipment right now, at the top, you can see there's a blue mask. That's actually an N95 respirator. that's our minimum protection that we're using at the bedside caring for these COVID patients, whether they're patients that are under investigation or patients that are positive. Down below that, you'll see a face shield. We want that face shield to cover all the way past the temple, just at the start of the ear. That's really important. There are a lot of models out there that are open on the top. That doesn't give that protection from droplets coming into the face. So we want to make sure that top of the face shield is closed. Basic surgical masks. We actually have people out there from our Ivan Young Academy sewing face masks from surgical wrap. Gloves are also very important. Shoe covers. We're not using shoe covers yet, but we will be getting there. So those are very important for us to have. Goggles are an alternative to face shield. Face shields are something that we would prefer because it protects the front of the N95 mask from contaminants. Also hair covers. Many of our providers want to be able to cover their hair, though it's not a CDC recommendation at this time. We probably will be moving in that direction as long as we have enough hair covers. Tyvek suits, this is more for your ICU and very critical patients. You've seen this on the news. Many providers, almost every provider on the news they're showing is in Tyvek suits, but we're not at that point yet. We're still using our gowns. And then bottom, I guess it's my right, maybe your left, is the PAPR. And we'll talk more about that later. And I know Daniel from Respiratory will be talking about that as well. Next slide. So personal protective equipment, I talked about our occupancy. You know, it's not that high at this time with these COVID patients, but currently our burn rate for our 3 hospitals is 1,095 masks a day. Face shields, we're going through 1,000 face shields. Gowns, about 3,000. Bouffant and hair covers, we're using at this point about 3,000 per day, 1,000 shoe covers. We're also using about 3,000 isolation gowns. And for our PAPRs, which are our respirators, the cuffs are disposable. We're using about 20 a day. When we would hit surge, our daily utilization of these supplies would at least double. So we would go up to 2,095 masks. We would use 2,000 face shields, 6,000 gowns, 6,000 bouffant covers, 2,000 shoe covers, 6,000 surgical masks. Possibly at that point when we're in surge, we would be going to coveralls, which are those Tyvek suits that you see. We would use about 3,000 a day and about 50 PAPR cuffs. So our current need for reusable, you can see what that is. I would say if we had a total of 6,000 reusable N95 respirators, which Darryl has been working very hard on, we've had many of our architects and engineers developing face shields. We would need about 6,000 face shields that are reusable for the organizations and about 50 PAPR cuffs and lenses. Current equipment needs that we see out there, about 30 UV boxes. This is for UV disinfection. We currently have 23 that have been made already from Professor Armani. So that's been very helpful to us. And also we need to have additional PAPRs or cappers. We're looking at additional ventilators and possibly somebody who can manufacture HEPA filters. Next slide. So we have approved disinfectants in the hospital that we're using. All of the equipment and supplies that are reusable would need to be able to be cleaned by 1, if not 2 of these methods. Our current method that we use most is the hydrogen peroxide, which is a 1.4% hydrogen peroxide. It has a 1-minute contact time, meaning that surface needs to be wet with the peroxide for a full 1 minute. We also use a disinfectant bleach. It's a 0.55 sodium hypochlorite solution or a 1 to 10 bleach dilution. That has a 3-minute contact time, but requires an extra step when we use that method because it does leave a residue. So we would normally wipe it with some water afterwards, but our preferred method for equipment is hydrogen peroxide at this time. We're also using UV disinfection. We're using that as a secondary disinfection. We would use our peroxide first before putting it into our UV boxes. And then we also have Pulsenon, which is our UV disinfectant robot, which we can use to disinfect some of our larger equipment. Next slide. So process for getting these devices approved at Keck. Number one, we want to triage. Is this a donation or is it for sale? We also want to look at, is this a novel, non-certified piece of equipment? For example, the face shields. These are non-certified, but very, very useful. So anybody that is providing that, please email Graciela Medina at med.usc.edu. She will then forward it to me, and then we will decide, yes, this is a design that we like. Then we would triage it to Darryl to see if this is something that could be produced in mass quantities. If you have certified equipment that you're willing to donate, gloves, masks, Tyvek suits, you would then use the donate protective gear at med.usc.edu. They will then forward those to me, and then I'll make sure that they meet our standard infection prevention needs. Step 2 would be Darryl for approval of any prototypes. Step 3, we want to ensure its infection prevention standards are met. Number 4, we want to qualify the deliverable based on need. And then step 5, we would then deploy it as emergency clinical use. So lastly, I'd just like to thank you all for your partnership in helping to keep our healthcare workers safe on the front lines, and stay safe out there.
You know, maybe 7 minutes or so, we have a question answer. I want to make this workshop largely discussion focused. So this is your time to ask Kim questions and kind of better understand what they really need.
Perfect. So we've got a list already. First, coming from, is it Zia Brooks?
Zia. It's Zia Borak. I'm Dr. Borak. I am Chief of the Division of Pulmonary Critical Care and Sleep Medicine at both Keck and County.
Welcome, Zia.
And I guess I put some of these people in touch originally, and thanks to everybody for working together so that we could get it organized and not have multiple groups kind of working at cross purposes. I probably know the least of all about this than everybody on the call, so I defer to Kim, but I guess just one comment, and I am a bit of a skeptic to begin with, and your chair knows that, is that the CDC guidelines have lagged behind the reality by at least 3 to 6 weeks. So their recommendations are way behind. So for example, there are now emerging recommendations that everybody should be wearing a mask, which is we've moved into that at Keck. It's slightly variable at County, based on there being very high asymptomatic transmission. So a lot of our estimates about PPE could change over time as the recommendations change. And there's always been a discrepancy between what we really need versus the guidelines, okay? In other words, a balance of availability versus guidelines. The second thing is we do also service the county hospital. County seems to be taking care of their own PPE, but I also view us as one USC. So it is possible that there might be even more needs if we were to take into account both. And then related to my first comment, in China, they were at the end when they got their act together, as far as we can tell, using bunny suits. So I don't want to imply that the reason we're not using bunny suits is because we're not in a surge yet, that only surge requires that. There is a consideration that in fact bunny suits might be the standard of care. That's just not the recommendation. But that goes back to my point about CDC being a little bit behind. And hair is potentially a major reservoir for the virus for those taking care of it. So I actually feel that head coverings should not be optional. And some of it's based on very sort of anecdotal data out there. But I think I read an article last night that came out in Nature that was very persuasive for me, because it's actually showing that unlike the other SARS and MERS viruses, which tended to replicate mostly in the lower respiratory tract. There's significant replication going on in the upper respiratory tract, which might account for why this is so infectious. I don't think it's necessarily the infectivity, it might be the site of the replication, which is allowing it to spread more easily. So those are my comments. Kim, I hope I didn't contradict anything that you were saying, and Daniel, you can take it on from that. And the reason that I'm so passionate about this is that my people are actually on the front line, so I want them to be protected.
So yes, that's why I did bring up the bouffants, that we are looking for even people who can sew those type of things to make sure we have enough, and the shoe covers as well. So, and the Tyvek suit is also on there. So I appreciate your comments. Thank you.
Dr. Gupta, this is Neha, Nanda. I'm the hospital epidemiologist. Can I just add something to what Dr. Borak said?
Absolutely.
Thank you, Zia, for chiming in. So I think to just add to what Dr. Borak just mentioned, this is very infectious, and the way we measure that, you must have already seen in so many papers, is the reproductive number, right? So the reproductive number is the ability of this virus to infect the number of people from the index patient. And that number for influenza is around 1.5. But for this, it's probably north of 3.5, which is more than SARS, but less than Ebola. And like Dr. Borak said, that the bunny suits is something we are invested in. And Dr. Borak, we are not going to wait for a surge. No. My hope is that in the respiratory units, our isolation wards, we are hoping to deploy those if we have a supply and appropriate education has been imparted to the stakeholders.
SK, is it okay if we move to the next question from Jill Henley?
Hi, excuse me, Jill Henley. So I come from the research side of things. So I operate the Biosafety Level 3 laboratory here at the Health Science campus. And my question is in regards to disinfection for possible reuse. I noted that there was no comment on the vaporized hydrogen peroxide. Is that something that your team is looking into, or is it just a matter of not having equipment or utilization? Can you just comment on that?
Kim, do you want me to take that?
Yeah, go ahead, because that is something that we're looking at, actually real recently. So go ahead, Dr. Nanda.
Yeah, so Dr. Gupta, I don't know if I've introduced myself. Should I go ahead and do that, or is, yeah.
You can answer the question now, and then you can introduce when you are.
Yeah, because yeah, Jill, I'm the hospital epidemiologist, and the medical director of infection prevention, the department that Kim is representing. So I'm very, very skeptical of all equipment where we are, you know, trying to mobilize it in the hospital. And the reason I'm skeptical is because we do not have at this time a standardized way of disinfecting / sterilizing these instruments, these equipments. Typically, the way it's done, as you may know, is that we create bioactive aerosols with the appropriate virus and then look at the log reduction based on the disinfection / sterilization technique that we use to reuse these equipment, to reuse this personal protective equipment. At this time, from my reading and talking to my colleagues across the country, the two modalities that we have specifically for N95 masks is UVGI and the vaporized hydrogen peroxide, like you mentioned. Between the two, I think what we know is that UVGI initially, we had some confidence in it, but as we learn more about it, we are not so excited about it. Hydrogen peroxide, we have little information because it's just been used in Ohio, as you may know, and therefore it seems to be more efficacious than UVGI. But to answer your question, yes, we are actively looking, and I'm hoping to collaborate with someone to actually look at the log reduction after we disinfect our personal equipment, so we have the avenue of reusing, so we have the confidence in that avenue.
So I'll just, one last response to that. So we've been using vaporized hydrogen peroxide for decontamination of risk group 3 agents for the last 5-6 years within our BSL-3 laboratory. So if you need any additional information, operation information, we're more than happy to reach out and help out with that.
So Jill, can I connect with you offline?
Absolutely.
Perfect.
Thank you.
Thank you both so much. We have a question coming in from the chat box from Vidya.
So, Tiffany, in
Yes.
the interest of time, I'm also paying attention because I know that some of our friends from Keck are under a strict, schedule,
Yes.
and they need to get back. So, in the interest of time, let's collect the questions. We will get them answered, but let's just move on to the next speaker at this point.
Perfect.
Great.
Hi, everybody. Can everybody see my screen?
Yes.
Okay. So I'm here to talk a little bit about the fabrication of PPE that we're doing both here and community-wide. Sorry, give me 1 second. Okay, so this is one of the statements that are driving what we're doing right now. Basically, the CDC gave a guideline saying if we don't have PPE, to wear bandanas. And we felt that that was unacceptable, and we have to find better solutions to that. So that's where we're at. Give you a quick timeline. On the 22nd, our Director of Imaging Services texted me about 3D printing masks, which he heard from his colleagues from previous institutions that he's worked at, that they are starting to look at these sort of extreme measures. We very rapidly prototyped one, and our process that we went through is we went and contacted immediately our infection prevention team, and then following that, we went to respiratory support and tested it with our respiratory support team. As you can see, in a course of 3 days, we then started sourcing into the community for 3D printing. And yes, and then following that, I've been essentially camping out here at Keck, trying to establish enough resources and enough 3D printed prototypes and masks ever since. This is a nice chart of my sleep patterns, if anybody cares. So what are we doing? So we're basically going and looking at what resources, non-traditional resources we can to make PPE. And our solution to this right now is creating a pseudo N95 mask. It's a 3D printed mask shell. We're using essentially off-the-shelf items that we can still obtain to create something that hopefully will pass the testing that we can give it. So that's a glamour shot that they took with when the reporters came. So we're basically making these hard masks. So right now we have about 50 of these completely built out and ready to be sterilized, and the filters put in and fitted for use. We currently have about 220 in the short time masks actually printed in the community. I want to give a shout out to 2 of the organizations that have greatly helped us. One is a maker group called Crash Space that has been sourcing their members and printing a great number of this. And the other is Sunweaver Creative, who we partnered with, and they've been invaluable with iterations of the design. So we basically got this model from a makerspace that is associated with MGH out in Boston. And we took this model and ran with it. We've also iterated this model. So we've actually created 2 models on the current branch for different sizes. As you can see, rigid masks aren't adaptable to different size heads and different size faces. So we actually have 2 models, one for larger faces and the other for more medium to I guess, regular size faces. And we are getting more every day. We have synchronized drop-offs. We have a network of people that are basically collecting all the masks across LA and bringing them over here to Keck. On the Keck side, we are actually going to be streamlining the finishing construction aspects of this, applying the seal, applying the filters, and also, before applying the filters, the sanitation. So what we're doing for sanitation, which everybody's been asking, is we're following our infection prevention group's recommendations of using the hydrogen peroxide, and then followed by UV sterilization. We've run some tests on the mask to see how it withstands these particular treatments. And after 5 cycles, it doesn't seem to have any effect on the materials that we're using for the mask. So we have some confidence that we are able to sanitize these masks fairly effectively. Let's see. I'll talk a little bit about face shields. I think Dr. Armani is going to talk a little bit more. No? Okay. We'll talk a little bit about face shields right now really quickly. So face shields are something that we can immediately deploy, but we have some design concerns. And since the face shields are designed to protect our frontline healthcare workers, these design concerns are actually major stumbling points that we have to overcome. Seth at the Dornside machine shop, I think he's on right now, Weeman, he gave us a design that has been very popular online, which is the Prusa model that has been printed out. As you notice, if you can see, the top of the Prusa model is actually open. And one of the issues with an open top is it basically prevents you from looking down, which a lot of our frontline workers might have to do, because that gives you a direction of possible infection. And also, the Prusa model itself doesn't cover all the way to the temples, so it leaves the eyes exposed from the side. And if a healthcare worker turns their head too quickly, they might be exposed. So our guidelines, and I'll talk about this in a second. So our next model that we have is a courtesy of Dennis Armani. His company, SMP Engineering, developed the second model, which actually is very useful. Dr. Armani has put this on the NIH 3D printing website. And for those of you that wants a personal one to use, this is a very good model. It covers the top. It's very lightweight. It's a large print, but it does cover all the bases that we're looking for. What we decided to do, though, is we standardized to the Budman version 3. This has the advantage of it has been certified already by NIH. Infection Prevention has tested it out, and they like the coverage. And finally, this is one that's also being sourced by Cedars-Sinai, as we found out through our crash space collaborators. They are already sourcing this. And so we're looking at mass production. If we're looking at mass production, we should try to get as much interoperability as possible. If there's already a source of these masks out there, we should be able to, if we're going to start generating face shields, to be interoperable with the face shields that are existing out there. So what we've done is we've standardized to this particular model. The most important part about these models is how is the face shield cut in terms of the hole placements for the attachment points. If we have any future models coming out, they will be standardized to this particular hole spacing, so we can adapt whatever sheets that we cut to whatever visor we might need in the future. These models are currently being iterated for speed, essentially, less material, faster printing time. So as we get new models, we've been putting them out just to try to increase the print speed. To give you an idea of why this is important, take a look at the difference. It might look slight, but if you take a look at the picture on the left, notice that it stops shorter than the picture on the right, and that slight difference actually was very pronounced on a lot of our larger head testees, and the side coverage is very, very important. Now, one of the things that we also want to point out is that everything that is currently being made or has been made will be used. Nothing is going to be going to waste. So all the previous models, the iterations that we're using, they will be used. And we are looking very much forward to trying to standardize in the future, but that does not mean we are not using all the things that we have iterated in the past. I believe I'm going to lead into Tucker's talk. I'm just going to show you a really quick picture. I believe you've already delivered to us close to 300 masks for the temporary variety, and as Kim has pointed out, is already being deployed. And I want to talk really briefly about what my design philosophy of this for the masks are in terms of the N95 masks. Basically, I'm approaching this as wartime medicine. I'm looking at this as the guidelines have told us to wrap pieces of cloth around our face or put a sock in our face as our protection methods if we run out. And I want to stress that all of this preparation in terms of the masks are in case we run out. And they're not trying to supplant the certified equipment. It is all in case we run out. So this is all worst case scenario situation for the equipment that I'm building with the N95s. And that's been guiding my design philosophy in that I am not as worried about trying to meet certifications on a normal operating level. I'm trying to meet a very simple goal, which is provide better than a bandana. And with that, I'm done with my presentation.
Fantastic. So our first question is coming from Vidya.
I actually had, hi, this is Vidya. I work for GE Research, and I got this link and thought I would call in. It's interesting. I had a question about a follow-up question to the sterilization. So I'm not sure if it was it was a follow-up to a comment from I think Dr. Nanda and Dr. Borak, and I think it's relevant to Darryl's presentation as well. Is for masks that are being sterilized, I understand that you look for you validate the sterilization techniques by looking at virus infection removal by a protocol. But what about if you're going to sterilize masks, N95 masks? What about the has the efficacy of the sterilized mask, how is that being validated?
Vidya, is your question that does it have the same filtration
correct
ability?
Yes.
Right?
Yes.
Yeah, so these are questions.
That's a critical question, isn't it?
Yeah, exactly. So a couple of things that I'm looking for, I don't think we really have the luxury of time before we proactively deploy this, yeah. But in an ideal situation, things that you want to make sure that our masks, which are the most important PPE, have is they have the integrity. We haven't compromised on that, and a piece of that is the filtration capacity, right? And the second piece is if we are going to reuse the approved N95 masks that are not the ones we've manufactured, we want to be able to look at those masks. How well are we decontaminating it?
So I was actually
another open question that you bring up, and it's a very valid question. And I'd love to work with someone to identify how we can get quantitative data and have confidence in what we are doing.
So Dr. Nanda, my original question had to do with the commercial N95, the certified N95 masks, because I have heard that they're being decontaminated and reused. perhaps, and I will get in touch with you offline. But for the kinds of masks that Darryl described, it sounded like the filter piece of that mask would be potentially disposable, but maybe I misunderstood. And it seems like then that would be easier to, if there's a mask where the shell that holds the mask to your face is can be decontaminated easily, because that's not the filter piece. The filter piece can be tossed after every use. Then maybe in that case, the decontamination is less of an issue. But for the N95, it seems like the validation of a decontaminated mask's efficacy should
Yeah,
be.
Vidya, I'd like to talk to you more. There are a couple of other things.
Sure.
In the interest of time, I don't want to bring
Yep.
those up, including shadow effect that comes into play
Yeah.
with N95.
Yeah.
Let's talk more.
Absolutely. Thank you.
Yeah, you are absolutely right. Actually, we are planning on just tossing the filtering aspect of these particular masks that we're making.
Yep.
Black doesn't seem to work very well. But what is so essentially, if we get large rolls of N95 material,
Yeah.
you know, we could potentially save a lot of material using this method. Because this material, basically, we only need like a 2-inch square of fabric to do the filtering, as opposed to an entire large swath for the cloth masks that are currently being used. And you're right, we're wiping down and UVing the rigid component.
Shell.
Yeah, the shell. One other large benefit of this particular model is that we have a grill in front. I'm going to turn off this entire virtual background because, okay. We have a grill in front, and that actually prevents you from actually touching the filter, which is a problem with the cloth mask, because if you take on and off your cloth mask, you will eventually touch the mask. This actually prevents the filter actually from contacting a lot of surfaces. So we have some hope in this design. And this is not a new idea. I mean, you know, 3M sells respirators with N95 inserts. It's just a matter of quantity and being able to get it. Plus, in traditional settings in the hospital, you're not going to have, you know, hundreds of these type of cup interfaces, because sterilization normally would be too long to go through and wipe down each of these. But in a disaster situation, these are kind of invaluable in that the fact that they can be reused very quickly, even with the sterilization. So,
thank you.
Again, I just want to stress that all our N95 or pseudo N95 masks are in case we run out of all other protection devices.
Darryl, I don't know if you added that we actually did fit check this mask, and it
Yes.
did.
Oh, okay. Yes, I do want to point that out. So we did do a fit test, which is mandated, I believe, for every person using N95 to do every year. For those of you, especially in engineering and architecture, that don't know what this fit test is, you basically have to put on a mask. They put you under a hood and they spray a chemical, and you breathe. If you can taste that chemical, it means that the mask fit. Generally, for the mask fit, it means that there's a leak somewhere. For our case, we're testing two things. We're testing fit and if the filtering material will filter out that level of particulate. It's a rough test in terms of you know, quantitative numbers. There are none. It's a qualitative test. But it is a standard test that they normally do inside the hospital to check for fit on N95. And so we've done that on several of our iterations of the mask, and they've all passed. But again, it's very subjective to whether or not the mask itself will fit on the person wearing it. But it seems that our filtering material that we've chosen, which is a HEPA filter that can be sourced commercially, seems to be working on par with our N95 filtration from this test?
It's the same test with the same challenges we have with the traditional N95s, with the same, I'm assuming, going to be rate of failure for the face fit, except that I think that these 3D printed masks are a better fit in general with a better seal in general.
Darryl, we're going to need to move on to the next speaker, if that's okay with everyone. Thank you so much. So let's move to Neha. Dr. Nanda.
Thank you, Tiffany. I sent SK a picture. I wonder if you could just project that for the group of the swab.
Yes, I can do that for you.
Okay, thank you. So what I'm going to do is I'll share with you what my request here is, and I want to get a sense if that's feasible or we can engineer that product. So as you may know, that the two things that are key for us to overcome or even ride through the surge or even in a non-surge setup is going to be testing and personal protective equipment. And we'll be talking more about personal protective equipment, but testing is very key. And the reason is that if I get a test back in time, I can actually reduce the amount of PPE I need. So testing is very important. At this time at Keck, we have the ability to test several patients. However, where we are lacking today, and that's our bottleneck, is the swab that we need to use to put it on the machine to test if that virus is in that patient. So let me just walk you through how we evaluate a patient. So when there's a patient and we suspect that he has COVID-19, the first thing I have to do is I have to take a swab. So this is the swab that I'm going to use to put it in the patient who I'm evaluating and kind of then roll it in the nose. I'm trying to get a nasopharyngeal swab. And then I take this swab, I put it in a vial. That vial either has saline or some media. Let's not get into the technicality of it. And that goes to the lab. In the lab, they take this swab and they isolate the DNA from it, and then they run it on the machine. And the machine is then going to tell us if the viral DNA is present in the swab or not. So you can see how having a swab is very, very important to be able to access tests, thereby being good stewards around using PPE. And at Keck today, we have the capacity to do around 200 tests, if not more, but the number of kits that we have with the swab, they are only 1,200, okay? And if we can design a swab like this, that would be great. I can send people specific catalog numbers of the most optimal swabs that we want to use in these patients, because it's not only having I'm sorry, Mia, I'm in the middle of something.
This is the first one.
Okay, I'm sorry, Mia, I'm presenting. Okay, sorry. What was that? Mia, 2 minutes, I promise. Thank you. So the swab, the swab is key, and that can help us a lot. The technicality of the swab is that it has to be a synthetic fiber with plastic shaft. We should not be using calcium alginate swabs or swabs with wooden shafts because that can inactivate the virus. That is really it. And yesterday night, I believe I sent SK a lab URL, the Forms Lab, where they actually have a 3D printer where they can do this. So I was just wondering, how can we start on a project with you guys so we can have an influx of these swabs and we can get the ball rolling in patient care and also being stewards around PPE. The ask would be about 5,000 swabs when possible. That's about what I have, Tiffany.
Dr. Nanda, this is Darryl. We actually are purchasing a Formed Lab 3D printer, specifically their medical grade, dental medical grade Form 3B right now. They're issuing the PO today. If they have a model that we can print those for you coming this week. I don't know what their entire setup is for this, but Formlabs, their 3D printers are resin-based printers, and we are getting one. So if we can arrange for a meeting afterwards and see what Formlabs is doing, we can probably, if it's using the same printer, replicate that. So just as a heads up on what we can do with that.
So
Thank
we
you,
also
Darryl.
have a printer at Center for Advanced Manufacturing, and Mithul just texted, he has 2 Formlab printer in his lab. So we have access to about 3 printers right now. So we can call Formlab people and get their design and see how we can help you.
That would be wonderful, SK, because this is really going to change the face of what's happening.
Great. So we have now quite a bit of time. So Tiffany, we can just take questions, and perhaps the next speaker can go on at 10:20. So we have about 30
Fantastic.
minutes or so for questions. So now.
Perfect. So we have our first question from Sean Chapman. Sean had a question about specifications of the swabs you like and the sort of quantity you need.
I did, but Neha, it looks like you have already answered it for me. You guys need about 5,000 quantity that you're looking for, and the synthetic bristles and the synthetic swab tips. Something like this would be ideal for like mold injection technique. This is something that can be cranked out really quickly at that quantity very cheaply. So, but I'll take that offline.
So I think the other thing, Sean, I should mention is, because when you put it inside the person's nose, it should be something that is flexible and doesn't break, because then you're dealing with another problem.
Do you have an idea of like what sort of short hardness you're looking at from scale? Say something along the lines of maybe a short 20D or something like that?
I cannot answer that question. I can give you the product and I'll let you
That's
assess
fine.
that.
That'd be perfect. And we can talk with Darryl about that as well.
Fantastic.
Okay.
All right. Vidya, did you have a question about the swab material and what makes it unique?
Yeah, I'm just curious if someone knows what's particular about it.
So Vidya, I don't know all the particulars. What I do know is there are other swabs that are available, and they have, it's the kind of material that it's wrapped with. It's polyester versus cotton.
Okay.
And cotton is not recommended, and it's polyester that's recommended.
Okay. And you will be sharing part numbers.
Yes. I'll send the catalog numbers, and I'm sure you have a keener eye for those things. Yes.
Thank you.
Fantastic. Frank Menjivar, did you have a question or just a comment?
Yeah, it was just regarding so when Darryl was talking, he was talking about I saw it on the chats that HEPA filters were being used. And I mean, I've kind of just been reading up on it because I've been curious about that for people that are printing this stuff and trying to use it. My concern is if, my understanding is that HEPA filters have fiberglass in them, and, you know, obviously that would cause a concern if you're breathing that material with fiberglass in.
Got it. Okay.
We're taking a look at it. We're taking a look at that. The filters we're using aren't just, I mean, they're commercially available filters, but I chose this filter because it's easily disassemblable. And when I took it apart, it's more or less stays intact. There's no need to peel off layers like a furnace filter. When cutting it and dealing with it and testing, I didn't notice any fibers coming off of it at all. It wasn't, so generally fiberglass material will create little shards, and that's what you worry about. We've seen none of that creation. There's no dust that gets created when we're cutting this. And when touching the material, it actually isn't causing any kind of itch, which I normally associate with having small fiberglass shards coming out. I don't have anything better than that right now, except for the fact that just from a material handling standpoint, I haven't noticed any effects on this particular type of HEPA filter. And I do know that certain HEPA filters are more rigid and are set to be more permanent. This appears to be much more of a fabric kind of material. So less chance of the fiberglass. Plus, it doesn't crunch. So in terms of when I'm manipulating it, I don't know if that is the best answer, but it's what I have right now for this particular solution. I also want to mention that I am testing out this surgical wrap material that people have been posting about. This was it Hylon H600. The problem that we've come up with so far is that it's actually too good of a filtering material in that you can't really breathe through it quite easily on the small patch that we're looking for. So we might issue that for people with really good lungs that want to train for triathlons and are okay with a little bit of oxygen restriction.
All right, we have another question coming in from Victor Ong about synthetic materials.
Hi, yeah. My lab is starting up and we're starting to work with electrospinning fibers. But it was mentioned that sort of the swabs needed to have or be made of synthetic fibers, and I was wondering specifically why synthetic fibers, and in that case, if something like PLA, which is a biocompatible material, could be used to electrospin in fair quantities, such fibers that have water wicking capacities and storage capacities for sampling.
So Victor, I'll try and answer that question. As I understand, CDC and CLSI and the lab world always recommends a synthetic fiber because with that fiber, so let me take a step back. The test is only as good as the sample. If the sample has a good inoculum of the cells from our nose, then our test has a higher accuracy. And it's believed that with the synthetic fiber, the inoculum or the cells that you actually get from your sample site is maximum. That's the reason.
Okay. Do you know, I guess sort of, or does anyone else know what kind of fibers are being used now? Is there an issue when we're creating these things? We can 3D print the actual filaments to make them flexible and rigid enough to actually reach into the nostrils to grab the samples. But in terms of the actual sample collection site, is that a different material? What kind of materials are used, and have there been alternatives looked at for if we're looking to fabricate them on sort of a more distributed scale using machines such as electrospinning machines that are capable of producing fibers pretty quickly?
I think some of your questions, Victor, may be answered when I send the catalog numbers of the optimal fibers, of the optimal swabs that we would want. I don't want to speak beyond my expertise at all because I do not know. This is what we are always taught. Go with a synthetic fiber, and I don't know any more than that.
Okay, thank you. I'll look forward to that list.
Okay, I think we have just a few more minutes. Rob, did you have a question about the geometry of the file?
Yes, I was wondering if we had any files that were already readily available for some of these swabs so we can begin experimenting with some ways of printing it.
Do you mean any files? I'm sorry.
Oh, sorry. I mean like 3D geometry files for us to use in the printing of the part, or possibly designing injection mold systems around it.
So
something we can work off of.
Lab on the URL has perhaps what you're looking for.
Oh, okay.
So in the chats, I just plotted, or I posted a link to the Form Lab Test Swabs website.
Okay, great. Thanks for that.
Yeah, and Rob, you'll also reach out to Formlab and try to see, what are their thoughts. And if they have some other thoughts, we'll try to collect that as well.
Will do. Thanks.
Okay. We have another question coming in from Dr. Barak. Zaya?
No, I didn't have another question. That was from before.
Oh, that's from before. Okay, let me take your hand down. Okay. I think we've answered all questions for Dr. Nanda. Can you please unmute and directly ask your question if we have not answered your question yet?
Yeah, if there were more questions for Darryl, when we had to at that time, because of Neha had to go, so we had to kind of cut that discussion short. So maybe if there are any question for Darryl, we can field them right now.
So this is Vidya again. I think it may be a follow-up to a discussion about the filters that Darryl was using. I thought somebody asked if there was a possibility of silica in the filter material and potentially something that might not be good to inhale. Was that a question or did I misunderstand that discussion?
Yeah, I believe the question was about fiberglass being used as a material.
Right. So
yes, and right
sort
now
that out fairly quickly by maybe whatever your filter material is. You could just have a cross section done at a USC materials characterization lab and check to see what's in it. A quick, it wouldn't take very long. Somebody'd prep a section and they could figure out what's in it structurally and chemically.
That's a great idea. If you can send me who I need to contact or who
You have to ask SK. I'm not a USC person, but.
I think the assumption you're making is that USC labs are currently up and running, and USC labs.
I'm sorry.
Yeah,
yeah,
USC.
Yeah. Okay,
yeah,
I may be able to help. Let me find out.
Yeah, I was going to say
Okay.
SC labs, like most academic labs nationwide,
Sure. Thank you.
shut down. Also, the question about the material choice. So there was an article in PLOS One, which is open access, and I put a link. So I think the selection of the swab material really has to do with the efficacy of the virus or bacteria or whatever release. And so that's why the specific material is.
Okay.
So it's, if you have another material that might work, but the material that they're made out of now is known to work. So, but I posted a link where they looked at several other materials and compared the efficacy of sample release in swabs.
SK, I think if there are no further questions, we can move on to Tucker's presentation.
Yes, if there are no further questions, then we can move to Tucker's presentation. We can give people 1 minute to see if there's any other question that people want to ask. And I want to definitely 10:20 get going with Tucker's presentation.
All right, last call. If you have any questions, unmute and let us know now.
I just posted something real quick. Is there an amount of time that if you had an N95 mask that was exposed to the virus, that if you let it sit in a clean environment, will the virus eventually die and then make the mask reusable at that point?
Yeah, there are guidance documents that guide the reuse of masks that are not going through a formal sterilization process. And in general, they recommend materials that are drying, like cardboard, as the surface for setting them on. They also give guidance for avoiding things like direct UV exposure, so sunlight, you can't leave them there. And some hospitals actually are using processes like that already, where they cycle masks through a third or fourth day. So stack them at home, 1, 2, 3, 4, and then they start cycling on the 4th day. But there are some guidance documents about that question.
Okay, and I heard that somebody had mentioned maybe shooting it with a blow dryer to heat it up. Does that speed up the process?
I don't know about any recommendations regarding that.
Okay.
So I wanted to comment. I've also heard about people throwing it in the oven and baking it essentially. I don't know if I think right now it's a lot of theory being thrown around, and then they're using it in practice. But I don't know if there's any good science behind it right now. We are trying to reuse a piece of equipment that was never designed to be reused, and things like whether the elastic starts degrading, whether the material is, other materials that are not actually part of the filtering material are breaking down. For example, the nose bridge and seal areas from all these different methods. Groups are posting online what they're doing, but I don't know if any of it's been truly validated by anybody. I think Dr. Nanda could probably talk a little bit more about that. But we've seen a lot of people post anecdotal procedures of what they're doing locally. One word of caution is that we found that even places that are considered reputable academic centers, in their hurry to publish as much information as what they're doing, might be putting out things that are not actually approved, and if you dig deeper, might be not supported by all the evidence out there. So maybe if Dr. Armani or Dr. Nanda could comment a little bit about that, maybe we can see what things we shouldn't be doing as might be a better thing than trying to figure out the best way, just to debunk some of the myths out there.
Yeah, Darryl, I'm not sure if Dr. Nanda's on anymore, but there are new guidances that just came out recently in the last couple days from the CDC that we are reviewing. So just so you know that.
Sorry, I just have one other final comment. So I don't know if anybody in this group actively monitors the ABSA listserv. So it's the American Biological Safety Association. So it's a group of all of the biosafety officers, both in clinical and research communities. So there's a listserv in which all these communities and institutions and universities are referencing the evidence studies that they are doing for the N95 decontaminations. And so one of the recent ones that's coming out of Stanford is the 70 degrees hot air for 30 minutes and the hot water vapor for 10 minutes, and how people are looking into converting catering services to reach those needs, and to be able to kind of take those types of, especially at universities, those large catering services, and to be able to modify them. But if I would say the ABSA listserv is another great resource to be able to ask people who have been doing these sorts of evaluations for decades if people aren't aware of that.
Good morning, everyone, and thank you to SK for putting this together and to Tiffany for handling logistics and slides. I am a digital fabrication lab specialist at USC Iovine and Young Academy. We have a really, really wonderful makerspace that just opened up this year, and I have been in conversation with folks from Keck and from Viterbi for what feels like ages now, but what has really been about 2 weeks, less than 2 weeks. Originally, my coworker Jacob Patapoff and I were looking at making the Prusa design-based reusable face shields, but even with our complement of 10 FDM printers, it was apparent that our output would be very limited. So right away, I was looking for options that would be more reliant on just our laser cutters. We have 3 fairly large laser cutters. I found a design from the University of Wisconsin's makerspace that they shared. I sent it over to Kim at the hospital. I went in last Thursday and met with Kim and Darryl for a few hours. We talked about design specifics and came up with something that they're actually using right now. I dropped 200 of them off at Keck on Tuesday, and we expect to drop another 200 off today. So you are currently seeing a finished face shield. It is extremely simple. It is a clear plastic shield with a non-latex elastic band stapled onto it. And then there is a polyurethane foam forehead rest. We've actually moved to using 2 staples on each side just as a backup. Next slide, please. So these are very, very quick to produce on a laser cutter. You could also cut the plastic sheet with a CNC mill, possibly a vinyl cutter, depending on the thickness of the plastic you're using. And if you have access to die cutting capabilities, you could really mass produce these. I know a lot of plastic suppliers also have very large format lasers themselves, so you could purchase pre-cut shields and assemble them if you don't have those capabilities. We are using a sharp utility knife to cut the foam. Some people have said they thought they needed a hot knife, but it cuts very, very well with just a snap-off utility knife, and we're using a standard stapler. As far as materials, it seems like any clear plastic between 0.008 inches and 0.02 inches works for these disposable models. There are plastics you would not want to use for something that you're going to wipe down and reuse. We have been using PETG, which could be reused. As some people have alluded to, sourcing some of these materials is getting trickier or less consistent. So we're going to try to continue to use the PETG, and we're actually going to move to the standardized shield design that Darryl was talking about earlier, so that there is the potential of removing the shield from these disposable models, storing it, and cleaning it and putting it onto the 3D printed headbands. For the elastic, we have been using hospital standard, oh, I have a typo, latex-free tourniquets. They're available in bulk, and if somebody needs to switch one out in the hospital, they have them on hand. We are using a soft polyurethane foam that's 1.5 inches thick and backed with adhesive. That's based off of a commercially produced design that I got from Kim. And then we're using regular stainless steel staples. Next slide, please. The design is a 9.5 inch tall, 13 inch wide shield. It's user modifiable, so if somebody needs to make this tighter, they can take a regular stapler and add another staple to the strap to bring it in. If they need to make the strap longer, they can remove the one that's on there and add a new hospital tourniquet. These are very easy to assemble. I personally put 200 together on Tuesday in about 5 hours. I recommend distributing the work if you can. My hands were pretty tired after that. We have spent about $2.50 per shield to make 480 shields. As the costs change depending on your source, so that's a good idea of how much these cost, but it does vary. We're getting our foam from McMaster Carr, and we're getting it in 24 by 24 inch by 1.5 inch blocks. If you go with like a polyurethane upholstery foam, you can get more easily and more cheaply, but you'd have to add adhesive. The commercially produced ones are glued onto the shield. I have not explored different adhesive options for that. We got our PETG from Solter Plastics, which is in Los Angeles. I know they're sold out for at least the next week. And the straps originally came from Keck Hospital, but are widely available. Next slide, please. So I have the dubious honor of having had jobs where I've done a single task repeatably and consistently. I'm an artist, so I've often done a lot of things in sort of a homemade assembly line format. So I wanted to give some workflow tips because the design is simple, assembly is simple. Pardon me. It makes a difference if you set up your workspace. So wherever possible, use laser cut guides instead of measuring. Arrange your workspace with dedicated work areas for each task so you're not moving things around too much. Do your prep work for a large batch before assembling. So don't take one shield and assemble it completely. It's more efficient to do things in groups. perform each step in batches, think about how to create an assembly line for multiple people while maintaining social distancing. In our fairly large lab, we have a maximum of 3 people at a given time, and we wouldn't want more than that, but even with just 3 people in 5,000 square feet, we want to be careful with how we lay out our production. When you're assembling these, the foam should be offset from the top of the shield by about 1/8 of an inch to keep the user's hair from coming in contact with the exposed adhesive. And I have a jig that I've designed to help do that consistently. If your clear plastic comes with a protective film, especially if it's the thicker material, leave it on while you're using the laser if you can, and then remove it before assembly. So that removes the step of having to clean combustion products off of the film. And it also, if you leave it on one side, a lot of users will think that the plastic is just cloudy. They won't know that there's a film on there that they should be removing. Next slide, please. So here's an illustration of my work table and the workflow. I have my pre-cut adhesive backed foam set next to the stacked and peeled laser cut shields. This light blue L-shaped object is an assembly guide that I've made that has an offset to help with foam placement. So I work through about 60 of these, just putting the foam on the shield, set them over to the right in stacks of 8. Once I've got 60, I move over to where I have my stapler and my bag of pre-cut straps. And quickly, I'm just putting 2 staples on either side and then making stacks of 8 to the right of that by our 16 by 20 inch Ziploc bags. Once I have 8 in a bag, I stack those bags, and before they get taken to Keck Hospital, every single bag is labeled with the number of items, our name, the date they were bagged, and then the materials. Next slide, please. So just some images from my production. On the left, you'll see I have this laser cut ruler. It's 1 1/8 inch wide and 26 inches tall. If you're doing the same thing over and over again, instead of measuring each time, try to make some object that is the size you want the final product to be, so that you don't have to do any thinking, any measuring. On the right, I've highlighted my clear L-shaped template. This is what I use to help with assembly. It also is the ruler that I use to cut down the elastic straps. Next slide. So here's the assembly of the foam and an illustration of how that jig maintains the offset. The jig is made out of 2 pieces, the L and then a block that's just adhered on top of that, pushed up 1/8 of an inch. I find that really helpful. Next slide. So completing everything in batches, doing stacks of 8. It works out very neatly. Our laser can cut 8 shields out of a single sheet. 8 of these shields, or finished shields, fit in one of our bags, so I keep things in that number. This also helps with counting, just cutting as many steps out of the process as possible. Next slide. That's it. Each bag is labeled individually so that Kim knows where they came from, when they were bagged, what material they are. I want to be very clear on the labeling that it is non-latex elastic, and we're trying to deliver these to the hospital in sets of 200 so that they can train to them and have a nice deployable set. That's all for my presentation. I'm happy to answer any questions.
All right, thank you so much, Tucker. We have our first question coming from Grant Delgatti about standard foam kitchen scrubbers.
Oh yeah, but I think Jacob answered it below.
Okay.
So Jacob, you said that it needs to be 1.5 inches thick.
Yeah, that helps the proper shield offset. And then it also has a certain length to kind of wrap around the forehead and provide that that shield from any moisture getting in.
Got it. Okay.
Yeah, it has to sit away from the face. Oh, sorry.
Tiffany, let's just take one more question and then let's move on to Daniel, basically.
Okay.
Yeah,
Great.
Tucker, you were saying something?
I was just adding that the shield itself has to sit far enough away from the face so that people with glasses can use it. It's not hitting their nose or contacting the mask.
I just want to weigh in on that really quickly. We did a lot of testing with infection prevention about the positioning of the mask. And two of the concerns that a lot of these models that have been put out that don't address is the fact that it needs to be offset for the head by that much. If you're going to be wearing a mask, it will fog up completely if it's touching that close. So the space is very important. And also the accommodation of people with and without glasses, that 1.5 inches is very vital. And if you take a look, there's a lot of models out there for the 3D printed version that doesn't have that spacing and becomes not only not usable, but very, very uncomfortable for people to try to adapt and wear. And that's been one of the model design concerns that we've been trying to work with infection prevention and the people that are actually going to be using these shields.
I'll just introduce myself. So my name is Daniel Stemen. I'm the manager here for the Respiratory and Interventional Pulmonary Services departments for Keck Medical Center. This lecture is designed for nurses usually. I give it to the Versant nursing program regularly. So what I'm going to try to do is just do some general ventilator overview and just sort of reuse this, okay? I didn't have time to throw a custom together for our session, so please bear with me. Are you ready to get started, Tiffany?
Ready to go.
Awesome.
Jane, is this set to go?
Yes, can you not see it?
Yes, we can see it. Just want to
Okay.
make sure it's in our view.
Well, go ahead and go to the next slide then. As many of you may know, there are many types of ventilators with a lot of software these days that govern the different strategies for ventilating a patient. And the keys that I kind of want to go over is what we're looking for in this emergency surge environment is some minimums for useful devices in this space. Since the COVID disease causes issues that would not be overcome with just a ventilation component, we need to focus on devices that can provide high levels of mean airway pressure and therapeutic pressures to provide oxygenation support to patients. Are you able to get into the slides a bit? We're kind of just sitting on the first one. So to summarize, we have this COVID problem. It causes a pneumonia. It causes a increase for needs for oxygen. And one of the key components in mechanical ventilation in terms of therapies is to use higher pressures in the lung to increase surface area of the lung, as well as reduce the oxygen membrane barrier, providing pathways for increased oxygenation and decreased shunting. Go ahead and move to the next screen. So just a brief history. Back in the day, polio, we had these negative pressure ventilators. They're super dangerous. It's very hard to regulate those safely, especially with where technology was then. And all modern ventilators today are positive pressure ventilators. Go ahead and move on. So these are the different categories of modes of ventilation. We can use really either or the control mode or the assist control modes for these COVID patients effectively. Since much of our strategies are going to involve paralysis and sedation, these two modes are going to be the core. Go ahead and move forward. These modes are going to allow us to ventilate the patients in ways that are effective and get the best use out of the devices in the most efficient way. One of the problems with treating these patients is that they use ventilators for extended periods of time. And so one of the things we want to be able to do is treat them as quickly and efficiently as we can so that ventilator utilization is optimized. Continue on. Assist control is the most common category of ventilator software. This category allows for a designed machine breath for the user to create manual breaths or machine breaths that are dictated by the provider and team. This mode also allows for patients to breathe spontaneously in the way of triggering breaths. Although in this mode, when they trigger breaths, they are triggering a machine breath instead of a more spontaneous or supported breath. Sorry if this is unfamiliar territory, but I'm just going to run through it as quickly as we can, okay? The mode that we're going to see used most often, I believe, will be, especially in these primitive and newly and rapidly developed ventilators, is going to be pressure control. So it's going to be assist control, pressure control. Let's move on. And we're going to skip that one. One of the other key components of mechanical ventilation for these patients with oxygenation needs, these hypoxic patients, is a very tight control over the PEEP. PEEP is positive end expiratory pressure. This is a baseline pressure that we use to help keep the lung inflated at all times. It helps us reduce driving pressure. It also helps us increase mean airway pressure to treat patients with high means to again support oxygenation. Let's keep moving forward. We're gonna just go over this quickly, but the pressure control mode, this is actually a good slide for those designing software for pressure control. This mode is going to be pressure set or pressure limited. Flow and volume, of course, will be variable when you focus on pressure. And we're going to use time to cycle the end of inspiration. So in effect, a pressure control software design is control over the time that the pressure is set, with all else being variable. And you also want to be able to control how often the breaths are given. This lets you design the total breath cycle with inspiratory and expiratory portions. Let's move on. We're going to skip that one. And so this is maybe not as important for this group, but the unfortunately, no lungs are the same. And so we do our best to treat them all individually with these machines. But in general, we have to make custom plans for every human that's mechanically ventilated. Let's move on. Compliance is a term that refers to the elasticity of the lung. This is a variable for many different pieces. A lot of it is the compliance of the chest wall itself. It can be a result of disease processes like fibrosis causing compliance changes. It can also be other issues in the body like sickness in the abdomen or pressure in the abdomen. All of these things affect compliance. Let's move on. Resistance is simple for probably all the people here to understand, but this is an effect of our circuits, the airways that we use. Resistance is affected in the disease side by secretions and things obstructing airways. Stenosis and disease process that cause different sizes in airways is how we look at airway resistance. Let's keep going. There's a couple examples of that on the next slide. Just for the nurses, we try to help them understand that, the smaller the tube, the more resistance. Continue. That one's just for fun. Continue. So the advantages we get out of this are control. We can isolate the patients this way by getting a closed circuit with filtration. It's an advantage in treating COVID since PPE as a whole is not totally effective. Isolating patients is key. There's some discussion around early intubation being good and bad, and I don't think we'll know until all this is over. Let's go ahead and continue. The main focus for the ventilatory side is keeping a balance of the patient's pH. Usually this is compensating for the amount of CO2 in the body, which we try to keep around 40 for most people. This is done by moving the right amount of air in and out of the lung while we have them sedated and not spontaneously breathing. Let's continue. This is the main challenge with designing a ventilator for COVID patients is controlling the amount of oxygen support that we have aside from the mix or the fraction of inspired oxygen we provide. And that's through mean airway pressure and PEEP mainly. Let's continue. We don't need that one. Continue. And actually, that's about done if you guys want to field questions. Because the alarms is the next slide.
Great. Thank you so much. We have our first question coming in from James Mertz.
Hi, Daniel. This is James from JPL.
Hey, James.
Quick questions for you. What are the control modes that are kind of a must need for a ventilator design that you're looking for?
I'd say the pressure control mode at a minimum is what we need.
Okay. And then how many are you needing and when are you needing those?
Ventilators?
Yes.
That's a very good question. At Keck, we have an uncharacteristically high amount of ventilators due to the acuity that normally lives within our facility. In terms of ICU capable or traditional ventilators, we have 49 that we would regularly use on patients. We also have 22 that we can use in the surge situation. So, you know, we have a pretty large amount of ventilators here. In the county, I would say there is a tremendous need for a lot more ventilators, and I don't know how to guess exactly how many, but it would be, I'm thinking, as many as we can feasibly afford to get together. I don't think there's too little right now.
Okay. And then the final kind of question I have for you is an FDA approval required for a ventilator, or are we looking to potentially relax that requirement, or what's the kind of deal with that?
The FDA actually has released a lot of information in the past week regarding ventilating patients and their devices. Traditionally, these devices would fall under the PMA or the 510K process for getting clearance from the FDA. Those processes have had releases from the FDA. As an example, Medtronic this week released and open sourced their ventilator that they were tasked by the government to design and build for this purpose, which I believe they only got to around 12,000-ish. It was supposed to be, I think, 80 or 100,000. They only actually ended up making about 12,000. That project was supposed to have been done in 2014 and then got pushed back to 2018. So as far as I know right now, they've made about 12,000. But they have released those designs and plans, and all you need to do is go to their website and give them your name and email, and they will release all of their design plans for that ventilator. That
Perfect.
ventilator
Thank you.
is sufficient to meet our needs.
Okay, did we have any other questions?
Yeah, and if you have questions for other speakers, so we could ask them now as well, and then we start basically moving to breakout rooms. So any other question for any of the speakers basically at this point?
Okay, fantastic. Then please bear with us. We're going to start the breakout.
One question, Stephanie, we just came.
Oh, okay.
Ozone?
Nick. Sorry.
Yeah, there are devices. Sorry, go ahead, Nick.
Nick, can you read your question?
I can read it if he's not on.
Sorry about that. Yes, my question is about ozone, O3, being utilized in purification cabinets. Not necessarily for mass areas, I know it's regulated, but about its effectiveness against the virus and sanitation on face shields or on cloth face masks, any utilization of ozone that we could employ.
Kim, are you still on? Would you like to comment, or I can say what I know about that?
I'm sorry, I didn't hear what he said. I was
It's okay.
doing another task.
So he's asking about using ozone for sterilization. What I know about this is there are some devices where this has been standardized for cleaning things like home CPAP equipment. As far as in the hospital, it's not a standard for us to use that. I don't know the limitations of that or the efficacy, but all ideas I think are welcome. They just require some investigation and validation. I don't really know if there's a feasible way for us to bring that into the hospital right now. What do you think, Kim?
Yeah, no, I think there's pretty good standard guidelines on the CDC website that just came out around decontamination, sterilization, what's acceptable. And I know Dr. Nanda is looking at that, like I said. So we're reviewing that together and hopefully more to come on that.
Awesome.
Thank you so much.
Jill, you're on.
Great, thank you. So I don't know if this is this isn't an actual question per se, but more along the lines of a request. I do have self-serving purposes besides just providing information. So as I mentioned before, so I operate the BSL-3 laboratory here at the Health Science Campus. And as of yesterday, we have just started our first SARS-CoV-2 infection. So we'll be doing the actual research, expansion, and work of the virus itself to start doing testing of therapeutics and other mechanistic aspects. So the PPE that we use, the personal protective equipment, is very similar to some of the needs that the hospital has. And we are actually lower on the totem pole when it comes to manufacturers and distributions. Basically, all the healthcare centers throughout the nation get kind of first dibs, and then the research labs we're told you'll just at some point wait to hear. So although our needs are smaller, obviously our researchers are doing expansions of these. The CDC requirement is biosafety level 3. So again, from the Tyvek to the actual respiratory protection helmets, we are also faced with kind of the same shortages. So again, I just wanted to kind of put that out that, depending on how this all pans out, we'd hopefully like to be able to request assistance and this collaboration should it be needed in the future.
So Jill, could you work with Kim so that way, we can have one channel to, and then Kim just let us know that, Jill needs that many, and then we can make sure that we can coordinate at the back end, basically.
That would be fantastic. Thank you.
Yeah, that sounds good. And me and Dr. Nanda, our partners, work together. So I know she's interested in talking to you as well. So
great. Thank you so much.
Yeah, so just let us know via Kim, and that way, once we have the projected need, then we can start saying who's going to do how many face shields and respirators and those kind of things, right?
Thank you.
Mm-hmm.
All right, we have a last hand raised from Seth Weeman.
Okay, I had a question from those of us who are producing some of this PPE before we go off into the breakout sessions. Kim had indicated that she was interested in knowing how many of these things we can produce, at what rate, and when we can make them available. In our case, it takes several days to determine that information reliably. We have to go through a number of setups and refine those to some degree to get those numbers. One thing that would be useful to know is, are there some quantities on these, some minimum production rate that one could quantify, below which one we should not even bother trying? I mean, before we go through this effort of figuring out what we can produce, if there is a rate of, say, if you can't make more than 10 a day, then it's not going to make a significant enough dent for you to go and investigate and optimize your process to give us what number you can produce.
Is that question directed to me?
I not necessarily. I mean,
Okay.
I'm just trying to, since we have no sense of what it's going to take to put a significant dent in the needs.
Sure. So when I said 6,000 face shields, that's covering our Verdugo facility, our Norris facility, and Keck. And that's all frontline providers for reusable. So if you're telling me, it would depend on how many groups are printing as well, right? So if you could do 10, somebody else could do 10 a day, and these are reusable, that makes sense, right? Because we could get a couple hundred out in possibly a short amount of time if we had multiple groups printing it. So for me to say it's kind of hard, I need to know what the resources are. And I mean, maximum, like I said, 6,000. If we say, okay, we can do 1,500, maybe focus those on one hospital or one area of the hospital. I kind of need to know what you guys are capable of producing before I can say what the minimum number would be, I guess.
So I was going to say, I look at my screen, right, and I see 25 people on the screen. And I say, if everybody who's on the screen can produce 10 a day for 7 days, right, which, may or may not be true, but that's even a week, right? That's 1,700 ballpark shields.
Exactly.
Right, like 1,700 is the significant
already
number.
if we had that many.
Right. So like I agree, like one person may not be contributing that much, but that's the whole point of trying to bring everybody together, is that as a community, we can make a big impact.
Exactly.
And just to reiterate on that point, we should all agree to the design we are following. We should not be each independently pursuing our own thread, because then the testing them will be very, very hard.
Well, I mean, agreeing to a standard design is a little complicated because we each have our different capabilities. And so a design which may be producible for one group may be more difficult to produce for another. Also, we're running up against different materials availabilities. And so if we can remain somewhat flexible on the design to accommodate different materials, then that might allow us to keep our production rates higher.
Yeah, so Seth, I totally agree with that. I mean, we're out there educating our healthcare workers that we want to ensure your safety. It may be a different color, it may be a different fabric, but it does the same thing. So I think getting one standard design is great, but if to get the amount that we need that actually meets our infection prevention requirements is 3 different models, I don't have a problem with that. I know Darryl is being tasked with a lot of emails. I am too. You all are welcome, the designers, to my cell phone as well. So we can make sure that what you can produce meets our needs. I will tell you, we will use it. Because I realize products are different out there. And, I mean, coverage is a big deal to me. And that's the main thing.
So in terms of the face shield designs, basically the way that we're looking at it is the headband portion is adaptable. We can print different models for it. If you're only capable of printing one of the designs, we're going to figure out designs that are universally available for the spacing on the face shields. So what we want to do is we want to standardize just the holes on the face shield. So if you're going to be cutting any face shields, they're interchangeable across the board. That's sort of the design constraint that we want to keep with as a minimum amount, right? And that we want to make sure that there's enough useful shield to cover our people. Those concerns are basically the only guiding factor in terms of the separate production of face shields and the band design. In fact, we realized that the band design is not going to fit everybody. And so we've been talking with designers to see if we can have other models that we can print smaller quantities of that will adapt to other people's head sizes, but use the same hole placements. So Seth, I will get back to you with the exact dimensions of for the face shield cutting.
Okay.
And I'll send you a couple of different models that we are printing for the headband design, if that would work.
That's certainly helpful. So I understand. Are we not using the SMP engineering standard anymore? That's
right now, since we're going with trying to get the city of LA to join in and partner with paying for a lot of this, we're trying to use a model that is standardized with CEDARs, just in case that we need to interact with them in terms of supply. And I think it makes a lot of sense to go with a model that they've already started deploying at their hospital, just so that we can supplement our numbers if need be. Talking to the maker spaces that are providing them with PPE, they've been standardizing to that this whole spacing that we the Budman version 3, version 4 that I presented earlier. And so if we can make all our productions the same, then if worst comes to worst, we can start sharing.
But can you upload the files?
Yes.
Because otherwise people can't access files.
I believe I've uploaded it to all the Slack. I will. I'm meeting with our web team right after this meeting to set up the entire website as the central download for Keck. They'll have the most up-to-date models. They'll have the most up-to-date information, and we will be putting in our disinfectant guidelines on what we think is the best procedures for that. And we'll make it as part of our COVID-19 response websites, so people all over can centralize and access. And also, for those clicks, they'll be able to see more information about COVID-19 on our main keckmedicine.org site.